This is our first part of the lesson on rational exponents. But before we get into rational exponents, we're going to take a look at some radicals. And we've done some of these operations before, and some of them are going to be a little new to us. So first thing, it says evaluate each of the following. And we start with the square root of 25. So hopefully we all know how to do the square root of 25. The square root wants to know what number squared gave me 25. Well, that would be 5 squared. Now, if you are having trouble figuring that out, that power sheet that I gave you, you could take a look, try to find 25. 5 squared is 25. Now, we are going to look at some different roots that we haven't seen before. This one here, you'll notice in the little check mark part of our root has a 3. That is not the same thing as 3 times the root of 1,000. This actually means something entirely different. This is what we would call the third root of 1,000. And what that means is we want to know not what number squared gives me 1,000, but what number cubed gives me 1,000. So usually I would try taking a look at this sheet, and I would look at all of my powers of 3 until I find one that matches. Now my last power of 3 here is 9 to the power of 3, which is 728, which isn't quite big enough for 1,000. Now 1,000, I notice, is a 1 with 3 zeros. So that's actually going to be 10 to the power of 3. So the cube root of 1,000 is going to be 10, because 10 to the power of 3 is 1,000. We're going to try part C. We have a little 5 in there, so that would be the 5th root of 32. So we're looking for what to the power of 5 equals 32. So I'm going to take my power sheet, and I'm going to look at the powers of 5, and I'm going to see if I can find one that equals 32. And I have here that 2 to the power of 5 equals 32. So the 5th root of 32 is going to equal 2, because 2 to the power of 5 equals 32. Now there is another way to do this. You can use your calculator. Most calculators definitely have a square root function, but if it's a scientific calculator, it should be able to do other roots as well. Now some calculators have a cube root button for the power of 3, but most of them will actually do any root that you want. Now the general rule for this, for most calculators, is that it's always going to be the second function of the button that you use to calculate exponents with. So on this calculator, it's my y to the x button. So this is a calculator where if I type in 4 times 4, I don't see it on the screen. So if I wanted to do the 5th root of 32, I would type in 32, and then I would do second function, or in this case it's inverse, my exponent button. And then I type in the 5 because I want the 5th root. And it tells me that the 5th root of 32 is 2. So all I need to do is the second function of my exponent button. Now this calculator here is a little bit different. The exponent button on this one is the caret, that little up arrow. Now this one, if I type in 4 times 4, I actually see 4 times 4 on the screen. So I have to enter this a little bit differently. Instead of putting in the 32 first, I would put the 5 in first, and then shift my exponent button, and you'll notice that the root showed up there, and then I type in 32, and I also get 2. So depending on your calculator, it's always the second function of your exponent button, unless you have a financial calculator or one of those statistical calculators, or a non-scientific calculator. So for the next 3, I'm actually going to evaluate these on my calculator. So the square root of 15, if you know where your square root button is, you can just use that. Or the number in here that we don't see on a square root is actually a little 2. So I could use my new button where I put in 15 and then my shift or inverse, my exponent button, and then a 2. And it tells me that the square root is that very long decimal. Or I could use my other calculator, it would give me the same answer. So this is approximately 3.872983 346. The next one is the fourth root of 25. So we're going to calculate this the same way. I'm going to, on this calculator, put the 25 in first, and then my shift or inverse exponent, and then I want a power of 4 in that little part there. So the fourth root of 25 is approximately 2.236067978. Now I think on the last one I will use the other calculator just to show you what that one does. I want the fifth root of 1002. So on this one I do have to put the 5 in first. So the fifth root, and then shift exponent button. 1002 is approximately 3.982662862. Oh, can't see that. Yeah. Now there are a couple of other radical operations that we want to talk about, and that is mixed radicals. Now we saw mixed radicals in our first unit on quadratics. So we're going to start with this regular square root of 75. So to write the square root of 75 as a mixed radical, what we do is we try to find the largest perfect square that divides into 75. Now I notice it's not an even number, so 16, 4, 36, 64, none of those would go in there. And I also notice that it ends in a 5, which makes me think maybe 25 might work here. So I'm going to take a look at 75 divided by 25, which is 3. So this I'm going to say is the same thing as the square root of 25 times the square root of 3. Now the square root of 25 is 5, and the square root of 3 is a decimal, so I want to leave it in exact form as the square root of 3. Now you can also do mixed radicals with other types of roots. So this is the cube root of 56. And if I try the cube root of 56 on my calculator, so I do the 3, shift my exponent button, and then 56, I get a decimal. So if I want to try to leave it as an exact form as a mixed radical, what I want to do this time is I don't want to find the largest perfect square. I want to find the largest perfect cube or power of 3 that would divide into 56. Now to help me with that, I am going to take a look at my sheet. We are looking at cubes, so that's going to be the second entry in each one. And we are looking at 56. So here, 5 cubed is 125, that's too big. 64 is too big. So really my only choices here are 27 and 8. So if I take 56 and divide by 27, I get a decimal. If I take 56 and divide by 8, it works out to be 8 times 7. So I'm going to say that this is the same thing as not the square root, but the cube root of 8 times the cube root of 7. And then the cube root of 8, well, 2 to the power of 3 gives me 8. So this is going to be 2 times, and the cube root of 7, I could check it on my calculator, but I know it's going to be a decimal. Now our last one is the fourth root of 810. So this time we're going to find a perfect power of 4 that will go into 810. So I'm going to look at my sheet. I'm going to look at the powers of 4. 2 to the 4 is 16. 3 to the 4 is 81. 4 to the 4 is 256. 5 to the 4 is 625. But I have to admit that the 81 jumped out at me because it is 810, which would be 81 times 10. So this is going to be the fourth root of 81 times the fourth root of 10. And the fourth root of 81, what number to the power of 4 is 81? Oh, I lost it. 3 to the power of 4. So this is going to be a 3 times the fourth root of 10. And that's it.